So let me explain something to you. I mentioned this in the previous lesson, but I'm going to go over this one more time. With everything that we draw on our screen, we are drawing it inside of a container of sorts. So for example, if I want to draw a stickman, that's a picture loaded in my memory, basically there is an invisible rectangle that surrounds that stickman tightly. So there's no, well, that's a terrible rectangle. There's no gaps. So it exactly fits our picture. And then we position it using the top left corner of this box. We often call this box a bounding box because it bounds our image together. And then, or bounds our image inside. So every box, just like draw a rect, has a width and a height. And we're going to use this in order to draw our images on the screen. What that means is that I can actually make that width and height anything I want, so I can scale my picture. So for example, if I wanted it half the size, then I would take the regular width and height of my image and multiply it by 0.5. So what I'd end up with is something like this. My imaginary box here, my beautiful, beautiful stickman, which I'm so amazing at drawing. And we'd get a mirror image, or sorry, not a mirror image, an identical image just scaled down. Just as likely, you could actually skew it too. Maybe I want to keep it the original height, oops, but I make it twice as wide. What it will do is it will stretch your original picture to fit the new shape. So you can see that my stickman is the same height but wide, a little bit chubby. So this is what we have to keep in mind when we create our programs. Sometimes this can be to our benefit though. We can actually use this for a lot of different purposes. Maybe we just want to stretch, maybe we have a standard platform size but we want to stretch it out to make it a little bit longer for gameplay purposes. But either way, whatever bounding box we put it in, it's that invisible container that stretches, that forces the picture to stretch out. You can almost think of it like a picture frame. That picture frame surrounds our picture and the picture is stretched to fill the whole picture frame. So going back into our program, we do this by setting up one single value that's a property of our sprite sheet, in this case our BG image. So in order to set up our bounding rectangle, all we have to do is change that one property of our background image after we've loaded the image itself, after we've loaded and set up the sprite sheet. To do this, we are changing the BG image dot destrec. Destrec is short for destination rectangle. It means where is the container, where is the rectangle going to be drawn, and how big is it going to be drawn on the screen. So what is our image going to fill basically? So let's keep it simple. Let's do it, let's say BG image dot destrec is equal to a new rectangle. Now if we're using this as a background image, then we want it to start at the top left corner of the screen. So where is it located? It's located at 0, 0. The next thing we want is the entire width and height of the screen. Now I know that my screen is 800 by 600 pixels. That's because that's the default size of our game window. And that's, if we look up, we set it up right here, 800 by 600. And that's fine. And that'll work, no worries. Of course, if you decide to change this later on, that means you're also going to have to change this down here because it's hard-coded. They're basically magic numbers. Not good. There is a way that we can detect what the width and height of the screen is, though. We could call a command that says gc, this is our game container, which basically is our window, gc dot get width. And that's a function that's going to return the number of pixels wide the screen is. Similarly, we can do gc dot get height. Why would you ever do this? Because at some point you may want to change the size and scale of the screen. So this is a very future-proof option. Similarly, we could do the same thing with our mushroom image. Now, I haven't actually set up the mushroom image sprite sheet yet, so we should probably do that first. I'm going to copy and paste this because it's easy. And instead of BG image, I'm changing mush image. And I'm loading a sprite sheet, but this time it's not from the backgrounds folder, it's from the sprites folder. And the name of the image is mushroom.png with a capital M. So we've now loaded our two images into memory. But I need to set the destination rectangle up for my mushroom as well. Before I get there, let's take a step back. I don't want to complicate things too much. Let's go draw our background. And the good thing is, when it comes to drawing the background, or drawing any image, it's actually really easy. All we have to do is down in the draw code, way down here, I'm going to do this. Well, I'm going to show you first. I'm going to draw it right here below our draw.text. And the command to draw our picture is draw.sprite. Now, we just need to supply two pieces of information for it. The graphics, which we don't have to touch, and the sprite. Which sprite are we actually doing? Well, we only have two, so I'm going to do BG image. That's all it takes. I don't have to do anything else. So now if I run my program, we get our picture showing up. But our text is gone. Where did our hello world go from our previous module? Well, the problem is, yes, it's drawn, but it's drawn before the background image. The background image takes up the whole screen. So that's no good. How do we actually do that? How do we deal with this? We deal with this by changing the order. Order matters. Basically, you're setting up a layer system. Whatever's drawn first is in the bottom layer. Whatever's drawn last is on the top layer. So if the background is drawn last, that means it's going to cover everything that's underneath it. So if I move that draw text after, we end up with hello world on top. So we can actually start manipulating our programs.